Hey guys, so this is part one of a new program I've created. It is a program which is going to be used to encrypt as well as decrypt and encode and decode specific messages that the user gives it. And it's going to give the user a few different options of the way they're going to either want to encrypt or encode those. So for part one, what I've completed so far is I have a menu, which is just a simple user interface. It's text based, it's very simple. And then we also have the first encryption and decryption functions, which is a Caesar cipher. So let's talk a little bit more about what exactly a Caesar cipher is. So if we go here, a Caesar cipher is one of the simplest and most widely known methods of encryption. It's just a substitution cipher. So what does that mean exactly? So a substitution cipher works by taking your plain text, which is the original message, and then it's just going to shift it over a certain number of characters, which is based on the user's key that they choose. So for example, a shift of 3 is historically what Julius Caesar used, and that's who the cipher is named after, obviously. So as you can see in this simple diagram here, if the letter E was encrypted using a Caesar cipher with a shift of 3, it would go back 3 places. So E goes to D, C, B. So now E is now B. So for example, if it was left shift of 4 instead, it would go D, C, B, A. So now E becomes A. Now, this can be pretty cool, but you might already be able to tell why this isn't very secure. There's only a limited number of letters, obviously, so it can just easily be brute forced. Specifically, there's only 26 letters in the English alphabet, and as a result, there's only 26 different options for a key. So this can even be done by a human in enough time. So let me show you very quickly how the program does this. So we're going to go into our program. It's going to ask us if we either want to encrypt or decrypt or encode or decode. So first we're going to do A. We're going to choose encryption. And then again, these are the these are the options that eventually the program will have. Eventually, it will also have base 64 and binary. These are not encryptions, these are encoding. And that's also going to have a different type of substitution cipher in which the user is going to be able to choose their own ciphertext alphabet. We'll talk a little bit more about that in a later video, and that's going to have an exclusively OR cipher, which is really the only secure cipher out of these 5 options right here. So let's stick to the video. So first, let's do A, which is Caesar cipher. So it's going to tell us that this is a low level of encryption and it's not secure, so this should not be used if you're actually trying to securely convey information. So first, it's going to ask us for our plain text. So we're just going to do something simple. We're going to say hello world, and we might as well use 3. So hello world now becomes this. This is our new encrypted text. So we can also decrypt it using this program. So let's do that. Again, we'll do the same one. Now B for decrypt. Let's enter the ciphertext we just got, which is, and it's going to show us, this is how the program is going to do it is, it's going to brute force it. And because there's only 26 different options, we're going to display all 26 of these, and then we can just see whichever one of them is human readable. So it's going to give us the 26 different options, and here we can see hello world with a key of 3. Now, this isn't the only way to do this. With text that's very small like this, this is probably the best way to do it. But with even larger messages being encrypted using a Caesar cipher or other substitution ciphers, it leaves you open to another type of decryption method, which is using frequency analysis. So let's talk a little bit more about what that is. So here's a frequency table. Basically, in the English alphabet, specific letters are used more in words than others. And there's research done in this to see which letters are used the most. So as you can see in the English alphabet, the most used letter is the letter E. So if you have more words in your ciphertext, it can tell based on the frequency of the letters. It can try and make a guess of what those letters would be in plain text. And the larger your ciphertext is, the more susceptible you are to this. So for example, just here, if we look right here in ours, there's two O's. So those would be L's. And you can kind of see how that would leave you open to being susceptible with the more letters you have. Because obviously the more words you have, the more likely you are for that frequency to be true. Let's take a little bit of a look at the code. So the code, let's start off just with the main function. The main function is very simple. It's just going to print out the user's options. It's going to ask them for a choice. It's going to convert that choice to uppercase just in case they didn't have that. And then we're going to have a switch statement here. And if they chose A, it's going to run our encode function. If they chose B, it's going to run our decode function. If they chose neither, if they entered something else, it's going to just do invalid choice and it's going to terminate the program. So let's get into the encode function again. Starts off very simple. It just prints out the different options the user has. It clears the input buffer just so we don't get any errors there when trying to take the input from the user. Then after it clears the input, it again collects input from the user to get which one of these encryption methods they want to use. Again, it's going to convert that to uppercase and get into our switch statement. So as you can see, the only one we have so far is the Caesar cipher. The rest of these will be coming in later parts of this video. Well, later videos. And so let's get up into the encrypt Caesar function. That's going to show us a little bit about how it works. So first, it's going to ask for the plain text from the user with a max limit we've defined as just 200 characters. Again, it's going to clear the input buffer right here, and then it's going to use fgets to get the plain text from the user. After this, it's going to also get the key from the user, again, just using scanf. And then from there, we're going to start printing out the ciphertext and converting it as well in this loop. So this loop just iterates through the plain text, looking for the end of it, which would be /0, and that's just when the user hits the enter key. And how we're going to avoid some errors as well in this is if there is a space, we're going to skip that. We don't want the space converted to an integer because then it's going to be a little bit weird and harder to decode. So we're just going to leave those as spaces, and historically that's how it was done as well. Spaces weren't really encrypted. So if it detects a space, you can use this function, which is in this library here, the C-type library. And if there is a space, it's just going to print the space out, I++, and that's going to continue in the function. Now, if there isn't a space, that's when we start encrypting, which is using this function right here. Now, this function is pretty basic, and if we break it down, we can go back into the Wikipedia page, and this is just the basic algorithm that's used to encrypt it. So it's going to take the letter, it's going to add it to the key, and that's going to do modulus 26, and that's how we encrypt. And decrypting is very similar, but instead we're subtracting and then modulus 26. So if we go back to the code, as you can see, we're adding the two together. Now you may be wondering what this minus 97 is, and that's due to when we're converting the plain text to a number, because when we're converting it to an integer, it's actually converting it to ASCII. It's not converting it to, just if it's A, it's not converting it to 1. If it's A, it will actually be converting it to 97. If we go to an ASCII table here, as we can see, the lowercase a starts off at 97, and from there it goes up. So that's why we have that minus 97 in there. That's to account for that. So then it's going to add it to the user key, modulus 27, and modulus 26, sorry, and then just again adds back the 97. So then it's going to print out the character, and then I++ is going to go on to the next character in the loop. If it's a space, it's going to skip it. If it's not a space, again, it will encrypt it, and it just does that till it reaches the end of the string. Now, the decrypt function for the Caesar cipher, again, is very similar. Again, it's going to iterate through the string in the same way, check for the spaces in the same way. The only difference here is instead of plus the user key, it's minus the user key, which is the same as right here. As you can see, this does work. We can go to other websites I like this one, for example. It has a nice little animation, and it will show us the same, much of the same. So again, let's run it one more time. Let's do hello world. Well, Caesar cipher hello world, and we get, let's do 3, and this is what we get. So let's go into here. We'll enter hello world with a key of 3, encrypt. As you can see, we get the same output. And then obviously if we decrypt it, we will get the same output as well. So yeah, thank you for watching this video. I'm going to make a second part soon, and in that second part we're going to be going over a little bit more of these different types of encryptions and encodings, and then also we'll be making the decryptions or decodings for them as well. Thanks.